the... Michael, what are you doing up there?
Nothing.
Get your butt down here. We gotta do a presentation.
Yes, sir.
Okay, so we'll be going over problem 9.5 and also 9.4 because it is part of it. So in 9.5, we will be using the results of problem 9.4 to calculate the fugacity of ethane at 320 K and a molar volume of 150 centimeters cubed per mole. Also calculate the pressure in bar. And for 9.4, we are going to derive the formula for fugacity according to the van der Waals equation. So we're going to start with 9.4 if you want to go over that, Michael.
All right. So to derive this formula for fugacity and uh and Gibbs free energy, we start off with a relationship up here in the top right that says G minus GIG over RT is equal to H minus HIG over RT minus S minus SIG over R. So that really helps us because we can solve for the departure functions of h and s, which we have already did and been incorporated into the equation already. Actually, if you look right here, the first part of this one over 1 minus b rho minus 2a rho over rt minus 1. That is the departure function for h, and then ln of 1 minus b rho, it should be plus, of course, because the negative is distributed. Plus, lnz is the departure function for s. We actually did this in a previous homework as well to find h and s. So we just combined them together, and because we knew the relationship with Gibbs free energy. Once we combined them together, um, you go through all these steps, and we went step by step, just changing rho into 1 over v, because we know that rho, the relationship between rho and v. And once we do that, of course, we end up with right here at the bottom, we have G minus GIG over RT is equal to V over V minus B minus 2A over VRT minus 1 minus ln of V minus B over V minus ln Z. And again, the reason why we did this is super important. Tyler will tell us later, but just to remind you that G minus GIG over RT is equal to ln of phi, which is very important in order for us to find fugacity, of course. And that's it for that.
All right, so now we're moving on to the rest of 9.5. So we have our givens up here where we've been given TV, TC, PC, and we need to find pressure. So we'll start by finding a few different things that are in the previous equation. We'll be able to find A using the equation 27 divided by 64 multiplied by r squared tc squared over bc squared. And for that, we get a very large number over there. We get b is equal to 1 over 8 rtc over pc, which is equal to 65.3. And using our equation right over here, we can solve for our pressure. So we want to fill in our pressure, fill in our values, and we end up with 65.42 bar. And we can use this pressure to find Z, so that way we'll plug it in. We'll be able to plug it into Gibbs, the Gibbs departure function. Our Z value that we get is 0.369. So now we have all of the numbers we need. So we can plug it into Gibbs, our Gibbs departure function, to get a value for that, which will end up being negative 0.461754. Now we know that the Gibbs departure function is equal to the natural log of phi. Um, and so we'll solve for that. So phi is equal to E over negative 0.461754, which is equal to 0.630177. Now, we can use that to calculate the fugacity of ethane. So we know fugacity is equal to phi multiplied by the pressure. So we plug those in, and we get a fugacity of 41.2262 bar. And that's it.
Perfect. Yep,
And we have a
that
cute
is
little
it.
picture of my cat. Isn't he adorable?
Yes.
He looks so concerned.
Mhm.
All right. Thank you
All
guys
right.
for coming.
Thank you.
You guys have a good day.
Bye.
Bye.